Hello world, I'm Everett, and this is Practical Python. Today we're going to do a super quick introduction to the PyTorch training loop. This is going to be everything you need to build a full pipeline from dataset on disk to updating model parameters. This will be a horizontal intro to everything, and I'll have other videos that cover each topic in detail. Without further ado, let's get coding. So we're going to start by importing Torch, and that's going to have everything we'll need except for a few data handling items. So from torch.utils.data, we're going to import the data loader and the data set. And so we'll get started now with managing our data pipeline. So essentially what we're going to need to do is feed our model with data that's in the appropriate shape, data type, etc. So what that means is that the X data can be accepted into the first layer of the neural network, and that the neural network output is the same dimensionality of our Y data. So for starters, we're going to create a class that extends the PyTorch dataset class. And so I like to have a two data fields here. So one is going to be a list of X data, and the other is going to be a list of the Y data. And the point here is that the same index is going to correspond to an X and the corresponding Y. So how you get your data into these two lists depends on specifics. So in my case, I'm using the Scifar 10 data set, which is images. So I'll be loading them in from disk as NumPy arrays, converting them to PyTorch tensors. And tensors are basically the PyTorch equivalent of NumPy arrays, but data going into Torch models needs to be of this type. So I'll code that up and see you on the other end. All right, so there we have it. So what I've done is basically just load all of my images from the disk and put them into the X and Y lists. So now what we need to do is implement two functions that the data loader is going to need to interact with our data set. So the first one of these is length, and so you can return basically just the length of X or Y. Either one should be the same length, otherwise you might have some problems. And then the next one we're going to need is the get item. And that's basically going to take I as an argument, and it's going to return the X and Y pair of your data. So that's pretty simple right there. Just return the item at I for X and Y, and there you have it. That's all you need for the data set. For the data loader, this is going to be much simpler. So let's make an instantiation of our data set, and I actually don't even need this variable here. Right, so take your data set, and for the data loader, all it's going to do is take your data set and a batch size, let's say 64, and I like to set shuffle, and it's really just instantiating an object, which is super simple. And so that is going to have all the functionality of combining all of your data into the batch sizes so that you can feed it into your network. So now if we run through this real quick, let's just see what we have here. So X is going to be the first item, and Y is going to be the second item. So it basically returns it in some iterable that should just be X and Y here. So let's just go ahead and make sure that, and so we want to check the shapes here, and basically that's going to let us know that it's the appropriate dimensionality to be passed into our model. For X and for Y, we want to check that the shape will be the same as the output of our model, right? And so what we're expecting here is to have a dimensionality of 64 by 3 by 32 by 32 for the images for X, and for Y it's going to be 64 again because that's the batch size by 10 because there are 10 different labels in our data set. So let's just go ahead and make sure that here, look at that, perfect. That's exactly what we're looking for. So that is good to go. So now the next thing we want to do is actually build a model. And so what we're going to do for that is create a class, and it's going to extend torch.nn.module. And what that's going to do is give it all the appropriate functionality to interact with the data for forward passing, things like that. So it's going to get a lot of code out of the way for us. And so the only thing we're going to have to specify is like what layers we want in our model. So let's just go ahead, get the super init out of the way. And so now I'm going to make a layer list here, and it's going to be a torch.nn.sequential. And so what sequential does is it takes in any amount of arguments, and as long as they're also torch.nn.modules, which again kind of equates to like a layer in a network, it'll just run through all of those layers sequentially, right? So because I'm using images, I'm going to be using conv2d layers. And so the specifics of your network might be different, probably will be different. And so what you're going to be using maybe are linear layers, conv1d, conv2d, etc. But convolutional neural networks and just straight feed-forward linear networks are pretty much the most common ones you're going to see. So I'll go ahead and create this and see you on the other side of that as well. All right, so there we go. I just finished up just putting all these layers into the layer list. And now the last thing that will be applicable for your model too is going to be implementing this forward method. And so what this is going to do is take a torch tensor, which is your x values. It's going to return a torch tensor. And basically this is just the output of running input x through your model. So for us, that's just going to be returning x going through that layer list, or whatever you wanted to call it, right? So there you have it. That's our model. And let's go ahead and just instantiate it here. So neural network is going to equal my neural network, and there were no arguments in there. So now we have a network here. One more thing here. Let's go ahead and make these floats. We want all of our data types to agree. So just make sure everything's a float. Should be good to go. So now here, what we want to do is just get our prediction, and the way it's going to work, just take my neural network, and we'll just forward the x data through it. And what that's going to be is the predictions that the model has. And of course, they're going to be very bad at first, but the idea is that with our optimizer, we're going to make it get better and better at predicting. And so next thing we want to do is check out what the loss from our model is. And so the loss is basically going to take these predictions, compare them to the y values, and basically find out how bad our model is right now. And so these loss functions, they're really just functions, and so you can get to them in two different ways. One is through the functional, this functional package here, and so we're going to be using cross entropy, right? And so we're just using the functional as if it's its own, as if it's just a function, right? So it's going to take the input, and that's going to be the predictions, and a target, which is the y values. We don't need anything else besides that. And again, this loss is just going to tell us how far off the predictions were from the y value. And so now to actually make the model learn, we're going to do what's called a backwards pass on the loss, and that's going to calculate the gradients from the model, and that's basically just how much each of the individual parameters of our model contributed to the loss, right? And so the last thing we're going to need is an optimizer, and that's going to be in torch.optim package. You can go ahead and, well, I'll have a video on these. Usually SGD or Atom are the go-tos. The important thing to know is that you just need to pass in the parameters, right? Which is what the optimizer is actually going to be in charge of manipulating. So the neural network.parameters, super easy. That'll just return all the parameters in our network, and the learning rate, which you probably have heard about. It's a fairly common hyperparameter. all the stock values on this should be pretty good. So we'll just use 0.001. All right, so now what the optimizer is going to do again is change the actual weights on the network so that it predicts less poorly, essentially, until we're getting good predictions. So the last thing to do is step the optimizer, which is going to actually update the parameters. But also one more thing we have to do is at the start of every pass in the model, we just want to zero the gradients in the model so it's using only the most recent ones. All right, so now you have it. Let's go ahead and see how the model predicts. So this should be the full loop. So let's just run it through and see how that loss performs. And all right, we just got to fix one thing. Let's see what that thing is. Ah, wrong one. All right, there we go. Let's go ahead and run this. Okay, so here's all we have to do. We have to make sure the output dimensions, again, the prediction and the y values agree. So what's happening right now is the prediction shape is not what we need. So because we passed in 2D images with 3 channels, it's going to give us an input that's also in 2D. So what we want to do is actually just kind of collapse that shape down so that it's in the proper shape. So instead of like a 10 by 1 by 1, we just want it in a 10 size vector. And so we can use the squeeze. And what that's going to do is just make it a 10 instead of a 10 by 1 by 1, right? So there we go. All right, so that did what we wanted it to. And so as you can see, there we go. Look at that. It's properly passing it through the model. So let's run one full epoch here and see how it goes. All right, so there you can see we made it through one epoch, and it doesn't look like that loss has changed, but what we really want to look for, especially in classification tasks, is the accuracy of the model. So I'm going to write up a quick accuracy function here, which is just going to take the predictions versus the y values, and essentially the way you calculate this is just to say prediction indices is just going to be the max values in the prediction, which is torch.tensor. All right, so we'll take the indices, the max values in the indices of dimension 1, and the indices of the max values from the y's. And essentially every case where the predicted indice equals the actual indice is going to be something that the model predicted correctly, right? So let's go ahead and return length of y indice where the predicted indice equals the y indice. Right, and again, that's going to give us our actual accuracy as opposed to just what the value of the loss was. So let's go ahead and just print out the accuracy of predicted versus y values, and let's see if that goes up. All right, so I thought I had an issue with loading the data. It turns out I didn't. I just didn't use multiple epochs here. So one more thing that we can do is run multiple epochs. And so basically one pass through the data is usually not enough. So in range, so what we're going to do is run 10 epochs of training, right? And so that's going to essentially go through the data set 10 times. All right, so I went ahead and made the optimizer Atom instead of SGD, and the overall effect is going to be that it trains much faster, just given that it learns how to update the parameters much more efficiently than SGD. All right, look at that. And we ended with about a 40% accuracy, which coming from 10% accuracy for random guessing is a much better improvement. So things you can do is like tweak the learning rate, tweak the batch size, tweak the number of parameters in the model, and you can see how your accuracy and the loss changes on your training epochs from there. Again, there's more videos on all of these topics individually, so if you want to do a deep dive into any of them, go ahead and check those out. Other than that, that's all I have today. Thank you for making it this far, and I'll go ahead and see you guys in the next video.